We've used Venn diagrams to organize our data, but there's these other things called two-way frequency tables, and we use these a lot. And you can imagine it means that it's the intersection of two different things. So we are looking at two different sets of categorical data. So, again, like a label, categorical tables data is a label. So like in our last example was playing volleyball is a label, and then we figure out how many people play volleyball. Okay. So we're going to use these two-way frequency tables, and basically they're just a chart that has a count of everybody who fits into whatever category it is. So they would fit into the category for the column, and they would also fit into the category for the row. And so we would put the number of people that fit into each of those categories. So if we were asking a survey of if you could have a new car, what would it be? A sporty SUV or a sports car? So we have these columns for SUV or sports car. And then we have these rows for male or female. So every male that answered SUV, we put here. Every male who answered sports car, we put here. Every female that answered SUV, we put here. Every female who answered sports car, we put here. And then you'll notice all these arrows that say add. So if I wanted to find out how many males were in my survey altogether, right, I could say, well, there were 21 who said this and 39 who said that. Therefore, there must be 60 total men in this survey. And then how many females were in my survey, I could just add them across. And then if I wanted to say how many people in my survey total wanted an SUV, I could add these down, right? There were 21 males and 135 females. So total, I have 156 people who want an SUV. And then for sports car, I could add 39 and 45 and get 84. And then I could add these together to see, okay, this is how many people wanted a sports car. This one. And this is how many people want an SUV. So if I add those two together, I get 240. If this is how many males I had, this is how many females I had, I should also get 240, right? Because these are just two different ways to label people. People fell into either male or female and either SUV or sports car. Okay, so when I add everybody who's male and everyone who's female, I should get 240. If I add everyone who wanted an SUV and everyone who wanted a sports car, I get 240. Okay? That makes sense? So how many people actually responded to this survey? Well, that would be 240. And then how many males responded to the survey? So oftentimes when you get a chart, it's not going to already be filled out right here, right? All of these are going to be empty, and they're just going to give you this, and you're going to have to figure this out. So if you were going to figure out how many males responded to the survey, you would just add up the males in that column, and we would get 60. How many people chose an SUV? Again, we just add up these two and we get 156. How many females chose a sports car? So now, instead of these totals, this is everybody who chose an SUV, but we're looking at just females who chose a sports car. So we're just looking at this group right here. So we're just looking at those 45 people right there. And then how many males chose an SUV? So that would be right over here, this 21 people. Okay, so now we can figure out probabilities. So first we were just doing a count. Like we were saying, out of 240 people, how many people said this and how many people said that, right? So your answer was like a number of people. Now we're going to talk about probabilities. And remember, probabilities have to be between 0 and 1, right? Because it's like 1 means 100% of people that I asked said this, and 0 would mean 0% of people that I asked said this, right? So if we want to find probabilities, we just use our formula for probability, which is favorable outcomes over or divided by total outcomes, right? So we say if there are 240 people total, what's the probability that if I picked one person from that group that I would get a male? Well, if I picked a male from that group, I would have 60 is my favorable outcomes, right? 60 people are males, and my total outcomes are 240. So we could simplify this if we wanted, but we don't have to in this case. It's fine if you want to leave it like that. If we wanted to simplify this, we'd get to 1/4. But that would say, if I was thinking, okay, I'm going to pick one person out of this group completely at random, what is the chance that I pick a male? It's a 1 in 4 chance, a 1/4 chance that I'm going to pick a male. What's the probability that I pick someone who prefers an SUV? Well, 156 of those people prefer an SUV. So 156 out of 240 prefer an SUV. So that would be the probability of picking someone that likes an SUV. And we could like put that into a calculator. I mean, we could simplify that down, right? But we could also put that into a calculator and just get like a decimal that is a percent, right? And so then you could say like, there's a 50 whatever percent chance of me picking someone who wants an SUV. What's the probability that it's a male who prefers an SUV? Okay, so now I'm getting a little bit more deep into this, right? So I'm not looking at everyone who wants an SUV and I'm not looking at just the males. I'm looking at males who prefer SUVs. So I only have 21 out of 240 people that if I pick one person at random, I would get a male who wanted an SUV.